Hello everyone. Welcome you all once again to my channel E-Learning and Creativity. In the last video, we have studied about various conversions such as decimal to binary, binary to decimal, octal to decimal, decimal to octal, octal to binary and binary to octal. If you have not seen that video, then you can see that through the link given in the description box. In today's video, we shall study about conversion of number systems such as decimal to hex, hex to decimal, hex to binary, binary to hex, octal to hex and hex to octal number systems. Now moving forward towards our first topic of today, that is hexadecimal number system. Now hexadecimal number system has base of 16 or it can be represented by H or HEX, hex. It has 16 distinct symbols because it has base 16, that is why it consists of 16 symbols, and that 16 symbols consist of 10 numerals starting from 0 to 9 and 6 alphabets starting from A to F, where A represents 10, B represents 11, C represents 12, D represents 13, E represents 14 and F represents 15. As both numeric as well as alphabetic symbols are used in the hexadecimal number system, so it is also called alphanumeric number system. The examples of hexadecimal number system can be 23A8, BC5, AF or FFFF and many more. Now here is one question, that does 289 represents hex number or not? Now here is the answer. Yes, it does. Why? Because 2, 8 as well as 9, all three digits are present in hexadecimal number symbols. 2, 8 as well as 9. Now we will come to the conversion first, that is decimal to hexadecimal conversion in case of integers. So process will be same as we have studied in binary and octal number system. So we have to firstly perform continuous division by the base, which is 16 here, and we have to repeat this division until the quotient becomes less than the base. Keep track on the remainders and for the result write them from bottom to top. This can be understood with the example given here, like 213 is a decimal number. Now we have to convert this 213 into hex number. Firstly, we will proceed by dividing this 213 by 16. By this division we get 13 quotient and remainder 5. Now this remainder will be taken as hex digit. Now further, this 13, if we divide this 13 by 16, then we have to multiply 16 by 0, so therefore quotient will be 0 and remainder will be 13. Now in hex digit, 13 is not a symbol. Equivalent to 13 there is symbol D, so 13 will come out as D, and we will write a result from bottom to top. So your answer will be D5 in hex number. So representation of 213 decimal number is D5 in hex representation. Now in case of fraction, again the rules are same as that of in binary and octal number system. So firstly we have to multiply that fraction part by the base and then separate out the left part of the fraction and then again multiply the right part of the result with the base. Now we have to repeat these three steps until the right part of the result becomes 0. And if it does not happen, then we can terminate this process after 3-4 steps. Now we have to keep track of the left part of every result, and answer should be written from top to bottom. So this can be understood by taking an example to 13.45. We have taken this example because we have done this conversion of 213 in the previous problem. So we will not repeat that because this is the integer part and we will only perform it for the fraction part. So fraction, we will take only fraction part. 0.45, we have to multiply it by 16. When we will multiply it by 16, we will get 7.20. From this answer, we have to take out this carry and rest of the part will go to the next step and it should be multiplied by 16 again. Then we'll get again 3.20. Now this 3 will be taken out from this answer and this 0.20 again go to the next step and multiplied by 16. Now again this 3 will come out as an octal digit. Now these all 733 are the octal digit. These all are taken out as an octal digits. So now you can see that this is an example in which this process will not stop. It will go on multiplying and you will get again 3.20, and again when you multiply this to, you will get a 3 digit out, and again when you will multiply 0.20 by 16, again you will get 3.20, and so on. It will goes on. So you can terminate after 3 point and it will give you the approximate value of your corresponding decimal number. So you have to write this fraction part from top to bottom. So answer will be D5 corresponds to 213 and 0.45 hexadecimal equivalent of this 0.45 is 733, which is written after this decimal point. Now hexadecimal to decimal conversion in case of integers. Now in case of integers, as these are also weighted numbers and each and every digit position has its equivalent weight as shown in the table here. So we have to just multiply the each digit by its corresponding weightage of that particular position. As digit 0 has a weightage 16 raised to the power 0 and digit 1 has a weightage 16 raised to the power 1 and digit 2 has a weightage 16 raised to the power 2 and so on. So we can understand this by giving example D5. We have to convert this D5 into a decimal number. So what we will do, this represents digit 0 and this represents digit 1. So simply the 0th digit is multiplied by 16 raised to the power 0 and this one digit is multiplied by 16 raised to the power 1, and simply by performing simple arithmetic we can get the answer 213, which is your decimal equivalent of hexadecimal number D5. Now similarly we can also take an example of a number, hexadecimal number, which consists of a point. So here 3a 0.2f is a hexadecimal representation and we want to get its decimal equivalent. So here it is. Now a is your digit 0 and 3 is your digit 1. Now after this decimal point your digit will be -1 and then -2 and so on. So it will goes like 16 raised to the power -1 and 16 raised to the power -2 and so on. So we'll get 3 into 16 raised to the power 1, a into 16 raised to the power 0, 2 into 16 raised to the power -1, f into 16 raised to the power -2. But we can't multiply a or f with any digit. So we have to convert its decimal equivalent. So a corresponds to 10 and f corresponds to 15. So in this way we will perform this arithmetic calculation and we get answer 58.183. So this is the decimal equivalent of the hexadecimal number 3a.2f. Now hexadecimal to binary conversion. Now hexadecimal to binary conversion is very simple. Just what we have to do, we have to replace each hexadecimal digit by its 4-bit equivalent binary number. As in case of octal number, we have replaced each octal digit by its 3-bit binary equivalent, but in hexadecimal we replace each digit by its 4-bit binary equivalent. Like if hexadecimal is 0, so what is the binary equivalent of this 0? It will be 0 0 0 0. We have to represent it in 4 bits, and for 1 we have to represent again it in 4 bits, and likewise up to 9. And after 9, what will be for A? A is simply 10. So we can represent 10 in binary like 1010. So this is the binary equivalent of the all hexadecimal symbols starting from 0 to 9 and from A to F. Also their decimal equivalents are also given in this table. So we will do this conversion by taking an example, like convert this octal number, sorry, it's not an octal number, it is an hex number. So it is an hex number. Convert this hex number, it is hex number, into its binary equivalent. So what we have to do, we have to just write all these digits separately, 2F 9A, and we have to write its corresponding 4-bit hex code or 4-bit binary equivalent, we can say. So 2 is represented as 0010, F is represented as 1111, 9 is represented as 1001, and A is represented as 1010. By combining all these, we can get this binary equivalent for the hexadecimal number 2F9A. Now binary to hex conversion, opposite of the previous one. Simply we have to make groups starting from LSB and moving towards the MSB in case of integers. But if we have a fraction part, we have to move from decimal point towards the right, making groups of 4. And we have to, after that, we have to replace each group by its equivalent hexadecimal code. Like in this example, convert this binary number into its hexadecimal equivalent. So we will make pairs, or we can say group of 4 like this. So I am just writing it here, and this number here, and this number here, and after decimal point we will write it like here. And now you can see in this example, on the right side of the decimal point we have left with only 2 binary digits. So when this case arises, when we are left with less than 4 bits, we can add 0. Now here we have left with 2 bits, so we can add 2 zeros. Similarly, on the left side we have left again with only 3 bits. So we have, it is a compulsion in hex conversion that we have to make group of 4. So we can add 0 in front of this. So now we can write this hex equivalent for each of this binary group. So 0110 corresponds to 6, 0110 again corresponds to 6, 0101 corresponds to 5, 1100 corresponds to C, and 1000 corresponds to 8. See, if you will not add this 0, then your answer must be wrong. You can see that 10 you can mistakenly signify it by 2, but it is not 2. It is, if you will not add 0, it is mandatory to make group of 4. So you must add 0 so that your answer is correct. So here is your answer 665.C8. Now here is one summary about all these conversion up till now which we have done, because when all these conversion will combine, there may be confusion in your mind. So to avoid that confusion, just make a pattern in your mind that whenever you want to convert decimal number to any other number system, so what will you do? Just you will divide by the base. and what that base is, that is 2 for binary, 8 for octal, and 16 for hexadecimal number. Just keep in mind that whenever you have to convert a decimal into any other number system. Now similarly, others to decimal number system, that can be done by multiplying by the powers of the bases respective to their position, bit position. In binary it is in the power of 2, in octal it is in the power of 8, in hex it is in the power of 16. Now binary to octal conversion. Binary to octal conversion is simply done by combining 3 bits, and octal to binary conversion by representing each digit into 3 bits, and binary to hex by combining 4 bits, and hex to binary by representing each digit into 4 bits. So this is all about the conclusion of all the conversion we have studied up till now. Now here one conversion is left, that if you want to convert octal to hexadecimal directly, how octal to hexadecimal. So it is very simple. Just what we have to do, we have to convert first of all that octal numbers. For example, let us suppose we have to convert 546.7. This is an octal number. We have to convert into hexadecimal equivalent. So what we will do, we will just write its binary equivalent of this 5. Remember that 5 is an octal number. So its binary equivalent will be in 3 bits. So 5 equivalent is 101, 4 equivalent is 100, 6 equivalent is 110, and 7 equivalent is 111 simply. Now what we will do further, just now write this sequence in the group of 4 starting from here. So first group will be this 0 1 1 0, second group will be this 0 1 1 0, and third we have left with only single 1. So what I have told you, that no one will remain separate. You have to add 3 0 in front of this 1 to make it group of 4. So likewise, after this decimal point we have left with only 3 1s, so we will add this 0. Now simply we have to write its hex equivalent of these group of 4 bits, like 1110 corresponds to E, 0110 corresponds to 6, 0110 corresponds to 6, and 0001 corresponds to 1. So therefore we can convert directly 546 into its hex equivalent, which is 166.E. Similarly, hexadecimal to octal conversion. In this also, just we have to write this hex number into its binary equivalent with a group of 4. Now after that, what we will do, we will separate out it in group of 3 like this. So we will write this 010 is here, and this 101 is here, and this 001 is here, and this 010 is here. Now what about after decimal point? Here is this group of 3, so we will write 110, and this 1 is left, so we have to add 2 zeros. So now we have to just write the octal equivalent of these groups. So 010 corresponds to 2, 101 corresponds to 5, 001 corresponds to 1, 010 corresponds to 2, and 110 corresponds to 6, and 110 again 4. So here is what we can do with a directly conversion of hex to octal and octal to hex conversion. Now lastly, I want to conclude that in general we have studied the number system with base 2, with base 8, and with base 16. But in general we can have number system with any base. So this any base, let it be R. So any number, a number expressed in a base R system has coefficient multiplied by the power of Rs. So this is a general equation. We have generalized the equation for any number system having base r. So this can be understood with the example, like let us suppose you have asked that 4021.2 is a decimal number system. Now convert this decimal number into a number system having base 5. So we haven't studied the number system having base 5. So it is very simple. Like what you will do according to this equation, this is the 0th digit, this is first digit, this is second digit, this is fourth digit. So what we will do, we will just multiply each digit by its corresponding weightage of position. Like 0th digit is multiplied, this is your 0th digit, it is multiplied by 5 raised to the power 0. Why 5? Because in the number system which we have to convert is having base 5. Here this 2 comes, here this 0 comes, and here this 4 comes. 4 is at third position, so we will multiply it by 5 raised to the power 3. And after the decimal point, again same thing happens. We will multiply this 2 by 5 raised to the power minus 1, because this is the digit minus 1. So when you will do all this arithmetic, you will get its equivalent, that is 511.4. Base will be 5. So this is a new number system which we have find out that with base 5. So in this way we can find out a number from the decimal number into a number system having any base, whether it is 11, whether you have studied it or not. With this all, I am concluding this video. For more videos related to this subject, keep watching this channel regularly and do like, share and subscribe for the latest update on the channel.